How's it going, everyone? It's Kyle here with another C programming tutorial, and in today's video we're going to be learning about pointers. Today's tutorial is going to finish our discussion of memory allocation, which we started 2 weeks ago when we talked about variables. And in today's video we're talking about pointers, which are one of the lower level features of the C programming language. So if you started learning programming with a language like Python, which is higher level, you've probably never heard of pointers before. So what exactly is a pointer? Now let's go back to 2 weeks ago when we learned about variables. We talked about how a variable is a symbolic method for representing some kind of number or logic value. So that value actually has a location in your computer's memory, an address if you will. So even if that number or logic value changes, its location in the computer's memory will stay the same. So now what a pointer is it's a special type of variable that points to another variable's location in memory, hence the name. So it's used to indicate where that variable is located in memory, or in other words, its address. Now that may sound kind of abstract to you, but lucky for you, I actually have a really good analogy that you can use to help you understand it a little bit better. I can't necessarily take credit for this analogy, but this is just the way that I learned it, and it helps me a lot. So imagine there's a house being built on the street, and this house obviously is built on the street at a specific address. The house itself won't move and the address won't change. It just stays there on the street. And that's what the pointer is. It's telling you where the variable's location in memory is. And no matter who moves in the house, so if you imagine the prospective buyer, whoever moves into that house, is the value of the variable, it doesn't change the house's address. Likewise, if you change the value of a variable, it doesn't change its location in memory. So that's how you can kind of think of a pointer, is it's the address of the house or the address of the variable in the computer's memory, which generally will not change. Let's see if I can give you guys some pointers on pointers. Now that you know on a conceptual level how pointers generally work, I can show you how we go about coding them in C. The way we define a pointer is similar to the way that we define a variable. So you're going to start by entering in the data type that you want to use. I'm going to use long integer, which is probably the most common type that you're going to encounter. Then what you're going to do is, before you give your pointer a name, you're going to type an asterisk, which signals to the compiler that you're defining a pointer, not just a standard variable. And then you can give it a name. And since I'm so creative, I'm just going to name mine pointer. And then you can punctuate that with a semicolon. Don't assign this to any value just yet. Next, what we're going to do is I'm going to define a regular variable just like we did a few weeks ago. So long integer, I'm going to call mine builderdude, and we're going to give this a numerical value of 35. And so now I've set up the pointer and I've set up a regular variable, and I want to assign this variable builderdude35. It has some location in memory right now. I don't know what that location is, but I want to take that variable and assign it to the location in memory that's specified by this pointer. So if I can bring this back to the house analogy to make this a little bit less abstract, what this means is, in the context of the analogy, the pointer is the house that has been built and it has an address, but no one lives in it right now. So there's no value stored in here. It's just a location in memory that's empty. On the other hand, we have our variable called builderdude, which has a value of 35. This, in the context of our analogy, is the prospective buyer, doesn't have a home yet, and is looking to move into this address, so this location in memory. Then finally, the way we would go about doing that is we'll add one more line of code where we put the pointer, so pointer equals, and then put an ampersand to assign the value of builderdude to that new address in memory. And then we can compile that, and it compiles without errors. So again, to recap, what we did is we defined a location in memory and we called it pointer. That was our address. And then we defined a variable called builderdude. That's our prospective buyer, has a value of 35, has some address in memory that we don't know. And then what we did is we took that variable and assigned it to the address in memory, the location in memory defined by pointer. And that's pretty much how most of the pointer operations that you're going to end up doing are going to look. What you just saw me do is define a variable called builderDude, which had a value, and move its location in memory to another location that was specified by my pointer. But you may be surprised to learn that it's also possible to do the opposite. I can define an address using a variable and then move the location of my pointer to the address specified by the variable. And I'll show you what that looks like right now. So first we start by creating a pointer. I'm going to make another one of integer type long, and I'm going to name this one point just because I'm starting to get lazy. It's late at night now. So that's our pointer, and now has been created. And I'm also going to create a variable, so of type long, and I'm going to call that variable, and I'm going to give it a value of 0. So this is just the same as like the first half of what we did before. Now the second line is going to be different, so I'm going to take my pointer, and instead of using the ampersand before, what I'm simply going to do is just say point equals variable, and then end it like that. And now what this is going to do is it's going to take this pointer and reassign it to the memory and location specified by variable, which is simply 0. Now a little disclaimer is that well, A, you'll probably never use this, and B, you probably shouldn't use this because this can cause a lot of errors. This is going to get into like more advanced stuff. The truth is, a lot of pointers, if it seems abstract to you, that's okay, and because a lot of it is. And truth be told, if you're using C for programming, something like EV3, you can have a long career as an EV3 hobbyist without needing to use pointers at all. But if you're looking to build an operating system or something like that, if that's the kind of stuff that you're into, then understanding pointers is very essential. But I just wanted to make sure that you guys at least have a cursory understanding of pointers while we're on the topic of memory allocation in C. Anyway, I'm glad to be able to give you a few pointers on pointers. Thank you for watching my tutorial this week. If you haven't already, click here to check out my new book. It's called Building Smart LEGO Mindstorm EV3 Robots, and it's now available on Amazon. If you found this video helpful, be sure to subscribe to my channel for more tutorials like this every Thursday. And if you have an idea for a tutorial, drop your suggestion in the comments section below. Thank you for watching, and I'll see you next time.